In this presentation, we will consider one special problem, that is palindromes. So let's get started. Before diving into the code, let's first try to understand what a palindrome is all about. We need to have some familiarity with the basics before diving into the code. What is a palindrome? A number or a word or a phrase, if read backwards, gives the same number or a word or a phrase as it is being read forward. So a palindrome is a number, or it is a word, or it is a phrase. If we read it from the backwards, it actually gives the same result as if we read it from the forward. Let's consider one example. Here in this example, as you can see, this number is 1221. If we read this number from the backwards, we can see this number is 1221, which is equivalent to the number that we read it from the forward. Now consider this particular word, race car. If we read this from the backwards, we can see that from backwards as well, this is race car only, right? Let me read this number now. This is 24542. If we read it from the backwards, again this is 24542. Therefore, this is also a palindrome. Okay? Now, the question is, what idea we need to adopt in our program so that we would be able to give this answer whether a particular number is palindrome or not. Here in this presentation, we will consider the program which tells whether a number is palindrome or not. We will not consider the strings here. We will only consider the numbers. Now, what idea we need to adopt? The basic idea is make last number the first number, second last number the second number, and so on. What does it really mean? It simply means that you need to reverse the number. Please note down, you simply need to reverse the number, and if the reversed number is equal to the actual number, then we can say that the number is palindrome. This simple idea we need to adopt in our program as well. Now our central idea is to reverse the number. If we would be able to obtain the reversed number, the rest of the part is easy, right? Let's see how do we able to obtain the reversed number. Now let me ask you one question. What happens when we divide the number by 10? Suppose we have some number, and if we divide that number by 10, what will happen? I will tell you one important property. When we divide any number by 10, then the remainder that we get is always the last digit of that number. And the quotient that we get is always the number except the last digit. Like for example, if we divide 456 by 10, the remainder that we get is 6, which is the last digit of this number, and the quotient that we get is 45, which is the number except the last digit. By using this property, we would be able to reverse the number very easily. How can we do that? Let's suppose we have a number 2332. If we divide this number by 10, the remainder that we get is 2, and the quotient that we get is 233, right? So initially we divide this number by 10 and we store the remainder inside the remainder variable. Always remember that mod operator is used to find out the remainder of any number. Now this is the logic we need to understand very carefully. Initially we are letting result is 0. We simply multiply result by 10 and add remainder to it. This logic helps us to reverse the number. After that we have q equals to q divided by 10. Q is nothing but denoting the quotient. We are initially storing number inside q, and then after that we simply divide this number by 10. Initially the value inside remainder is 2, right? As when 2332 is divided by 10, the remainder would be 2 only. After that we multiply result by 10 and add remainder to it. Now as result is 0, therefore 0 will be added with remainder, that is 2, and it will be stored inside this result variable. After that, we simply divide q by 10. Therefore, q will now contain value 233. Now what is the next step? We again divide q by 10 and store the remainder. As q is 233, therefore remainder variable will contain 3. Right? Now what is the next step? We simply multiply result by 10 and add remainder to it. As result variable contains 2, we multiply 2 by 10 and add 3 to it. Now the result contains 23. Now what is the logic behind that? If we multiply 2 by 10 and add 3 to it, we would be able to reverse this number. Previously the number is 32. If we want to reverse this number, that is, if we want to make this number 23, we need to multiply 2 by 10 and add 3 to it. This logic makes it 23. And that is what we are doing here. Now the result variable contains 23. After that, we simply divide q by 10. After dividing q by 10, now q contains 23. Then again we repeat the process. We divide 23 by 10 and store the remainder. Now the remainder contains 3. And then what we do? We again multiply result by 10. That is 23 by 10. Now it becomes 230. We add remainder to it. That is 3. Now it becomes 233, which is the reverse of 332. Right? Again we repeat the same process and finally we would be able to obtain the reverse of this number. This is the logic we need to understand. Now definitely the final step is to check whether the result is equals to the actual number or not. And if it is equals to the actual number, then the number is palindrome. Otherwise it is not a palindrome. Now let's see how to code this particular logic. Here you can see I have one printf function, and inside this printf function I'm printing please enter the number. That means I'm asking the user to please enter the number. After that we simply accept the input from the user. Then we put this inside the q variable and we put this whole logic inside the while loop. And here in this while loop we are checking the condition that q must not be equals to 0. Now by checking this condition, we can get outside of this loop if q is equals to 0. That means our quotient is equals to 0. This simply means that after obtaining the last number of our reverse number, we should get outside of this loop and check if result is equals to n or not. If result is equals to n, then we can simply say it's a palindrome. Otherwise we say no, it's not a palindrome. Let's execute the code now. Here suppose I enter the number 2332 and hit enter. It says it's a palindrome. Let's execute the code once again. Let's enter some other number which is not a palindrome, like 6785. It says no, it's not a palindrome. Therefore, this means that our code is working fine and we are successful in making the program which checks whether a number is palindrome or not. Okay friends, this is it for now. Thank you for watching this presentation.